Hello, good evening, students. How are you all? Good evening, Deepak. Okay. So, yes, how your studies are going on? Are you all studying? Yes. I think your practicals might be approaching now, right? Okay. Good, good. Good hearing from you all. Good. So study like this only. Okay, don't get nervous. Study cool, calm, your cool mind and calm mind. Okay, fine. So you have to do a smart work. Okay, not a you should not go on doing rattamar. Okay, you have to do smart work. So when you are studying, you have to do the smart. Okay, so you know now which are the important questions, right? From which part, which concept is important, from which particular concept you will get, which particular chapter you will get good marks, right? So what all things you have to study. So these all now tricks you know now, right? Yes. So moving forward. So we have started in the last class, we have started with uh, aldehyde, ketones, and carboxylic acid, right? Right. So in our previous class, we have started with aldehyde, ketones, and carboxylic acid. So this particular functional group, you can see what is common in this functional group, aldehyde, ketones, and carboxylic acid. Yes, what is common in this particular groups, students? In this functional groups, what is common? Yes, which particular, what is common in these functional groups? It has a carbonyl carbon, right? It has a carbonyl carbon. Yes, C double bond O. Good. Yes, Deepak, it is right. So you have a C double bond O, right? You have a carbonyl group. So these are the functional group or compounds which is consisting of carbonyl compounds, right? Aldehyde, you have a C double bond O H, right? Ketones, you have a C double bond O, okay, R and R dash. So your only one alkyl or aryl group is there, your both alkyl or aryl group is there. Then carboxylic acid, C double bond O OH, right? So your carbonyl group is the common. Okay. So we are studying what? We are studying about carbonyl compounds. So this particular chapter, as you all know, this is for 14 marks. So your U chapter wherein you will get 14 marks. Okay. So if you are good in organic chemistry, so don't miss this particular chapter. Okay. So as you know, so in organic chemistry, so the name reactions are very important, right? So for 2 marks, okay, for 3 marks, so you'll be getting name reaction. Then for 1 mark, what you'll get? Okay, 5 marks, as you know, in organic chemistry, they don't ask direct questions. So it can be 2 plus 2 plus 1 or 3 plus 2 question. Okay, like that. So for 1 mark, they may ask you what is IUPAC name. Okay, they can ask you like give reason type question. So, okay, so like this questions can be asked, but 2 marks, 3 marks, the common questions can be your name reaction. Okay, name reactions, either applicative type or it can be a direct question. Explain Rosenmund reaction, explain Carin-Zaro reaction. Okay, explain your aldol condensation. So these are the name reactions which can be asked directly or it can be asked in the different manner. Okay. So you have to, so the question remains the same. Okay, the answer, whatever you need to write, it remains the same. Only thing, the way they will ask, it will be a bit twist. Okay, it can be a twist or it can be a direct question. So as the question, Okay. So that only. So because see, as you know, in chemistry we had 16 chapters. Okay. As in chemistry we had what? We had 16 chapters. Okay. But now they have reduced to 10. Now they have reduced to 10. So previously how it was? So in this 16 chapter, your 70 marks were distributed. But now for 10 chapters, they have distributed this 70 marks. So the what this is increased what the what do you say mark distribution for each chapter has been increased, right? So now the level of asking question also will be a bit difficult. Okay, it can be asked in, you cannot expect a direct question, you cannot expect a direct question so directly. Now suppose if I give an example for SN1, okay, they cannot ask you explain SN1 mechanism with the example. Do you expect such a questions from the examiner? No. Okay, they cannot give you direct question, explain SN1 mechanism, give an example. They can, the question can be, okay, explain. I am giving you a reason, sorry, example, show the conversion from tertiary butyl alcohol, okay, sorry, tertiary butyl bromide to, or explain the conversion of tertiary butyl bromide to tertiary butyl alcohol. Okay, so this like this, it can be like this question. So can you understand whether it is what they have asked you? No, right? So you have to go through now. Then you have to apply. So that is what tertiary butyl bromide. Okay, tertiary butyl bromide to what? Tertiary butyl alcohol. Right, means what? Okay, so this is the SN1 mechanism. Okay, so like this, the questions can be. You cannot expect direct question. Okay, forget, don't expect direct questions. It can be in a twisted manner only. Okay, even the name reaction. So in your paper, okay, there might be name reaction, but they might have asked in a twisted manner. Okay, they might have what? They might have given you complete the following. Okay, they might given you complete the following. I'm giving you example. Okay, so this can help you to like to be more what you can say more okay uh, alert next time. So suppose if I give you like this. Okay, I'm giving an example. So plus 2Cr2 2Cl2 in the presence of CS2. Okay, undergoing hydrolysis. Okay, so yes, complete the following. What can be the product? What can be the product here? This is a toluene. Okay, so toluene is converted. Yes. So they're not asking you what is the reaction. Okay, they have asked you what is the product. You have to answer the product. So what can be the product here? It is benzaldehyde. Okay, so like this, the question can be like this. Yes, good. Okay, so like this, they can ask you. Or a bit twisted manner. Okay, they can ask you twisted. Now, so whenever you have nitriles, you might have seen nitriles, right? So they may ask you, okay, write the preparation of ethyl phenyl ketone, okay, by using Grignard reagent. Okay, this can be a question like this. What question? That is, you prepare, okay, prepare phenyl, ethyl phenyl ketone, okay, using Grignard reagent or using Grignard reagent, prepare ethyl phenyl ketone, okay. So how you can use, then you need to know what is the starting product. The starting product, if you use your propane, okay, you need a ethyl phenyl group, okay. So I can take a propyl group. So that is CHC, CH2, C triple bond N. So this is a nitrile plus C6H5 MgBr because I need a phenyl group, right? So phenyl group and a ethyl group. Okay. So this nitrile will remain like this only. So in the presence of dry ether. Okay. So and followed by hydrolysis, what you will get? You will get CH3, CH2, C double bond O. This is converted to C double bond O and C6H5 plus Mg, Br and OH like this. Okay, so like this they can ask you. They will not ask you. Okay, directly. Nothing is asked directly. So you need to do some smart work in like this month. Okay. I hope the things are clear. Okay. Don't be in that at least chemistry paper, because rest all um, subjects, okay, what they have done, small part they have deleted, okay, but in chemistry they have entirely deleted the complete chapters, okay, 6 chapters have been reduced. So the 10 chapters, okay, you have to study in the depth, okay, you have to study in the depth. So whatever chapter you are holding, you have to study it in the depth. You cannot just turn the pages, okay, you have to study in the depth. Fine. Okay, so moving forward, so in the previous class, we have completed the synopsis, this what, MCQs, right? We have completed the MCQs. Okay, yes, we have completed the MCQs. So we are going to see some of the important name reactions. Okay, so these are some of the important name reactions that we are going to see now. Okay. Okay. This mechanism we'll see at the last. Okay. Mechanism we'll see at the last. This is for 3 marks. So these are the name reactions which are asked for 2 marks. Okay. This can be asked for 2 marks. So first is which? Rosenmund reaction. First is what? Rosenmund reaction. So in Rosenmund reaction, what is done? We are taking a acyl chloride. Okay, that is acid chloride. So what we are doing? We are doing hydrogenation. What do you mean by hydrogenation? Hydrogenation means we are adding hydrogen molecule in the presence of catalyst. Okay, it can be a palladium. Okay, and barium sulfate. So we are taking a catalyst. What is the role of a catalyst, students? What is the role of a catalyst? What is the role of the catalyst? What is the role of the catalyst? Yes, it increases the rate of reaction. Okay, suppose means what? Okay, suppose this particular reaction, that is conversion of benzyl chloride to benzaldehyde, is taking around 5 hours. Okay, so by using this catalyst, that is your palladium and barium sulfate, the time is reduced to 2 hours. Okay, so it is what you're doing. The rate of reaction is increased. Okay, so catalyst, okay, it won't alter the reaction. It will just increase the rate of reaction. Okay, it will fasten the rate of reaction. So this is the role of your catalyst, palladium and barium sulfate, which is used. Okay, so what we are doing, we are taking a acyl chloride. Okay, we are taking a acyl chloride. Okay, and we are doing hydrogenation. Hydrogenation means addition of hydrogen over a catalyst. Which catalyst? Palladium on barium sulfate. Okay, and we are getting a benzaldehyde. What we are getting? We are getting benzaldehyde. So your benzyl chloride is converted into benzaldehyde by doing hydrogenation over a catalyst, palladium on barium sulfate. So this is Rosenmund reaction. So what you are supposed to do? You need to write the definition, okay, and the particular reaction. So this carries 2 marks. Okay, so this carries 2 marks. Okay, so this is the particular reaction, Rosenmund reaction. Next is Stephen reaction. Next is what? Stephen reaction. So in Stephen reaction, what we are doing in Stephen reaction? So in Stephen reaction, we are taking the starting product as nitriles. Okay, we are taking nitriles, that is RC triple bond N. Okay, nitriles. Then what we are doing? We are doing reduction. So we are reducing our nitriles to imines. Okay, imine is what? CH double bond NH. Okay, what is reduction? Reduction is addition of hydrogen. Can you see addition of hydrogen here? Yes. So this is a triple bond. So what is happening? Triple bond is broken to double bond and there is an addition of a hydrogen. So your nitriles are converted to imines. Okay. Converted to imine. Okay. So this imine is further it undergoes hydrolysis. Which hydrolysis? Acid hydrolysis to give you aldehyde. Okay, so from this preparation, from this particular reaction, we can prepare our aldehyde. So this particular reaction, that is Stephen reaction, is a reduction reaction. Okay, what we are doing? We are taking nitrile. Okay, a nitrile. Okay, with the nitriles using your this stannous chloride in the presence of hydrochloric acid. Okay, stannous chloride in the presence of hydrochloric acid. So this is acting as a reducing agent. This is acting as a reducing agent. That is, it is converting your nitriles into imines. Okay, so it converts your nitriles into imines, followed by acid hydrolysis to give you aldehyde. To give you aldehyde. So this is Stephan reaction. This is your Stephan reaction. Next is Itard reaction. Next is what? Itard reaction. Okay. Now what is Itard reaction? In Itard reaction, what you are doing in Itard reaction? Chromyl fluoride. Okay, chromyl fluoride. This is a oxidizing reaction. Okay, this is a oxidation reaction. What do you mean by oxidation? Addition of oxygen. So we have to use a oxidizing agent. So which oxidizing agent we are using? We are using chromyl chloride. So which we are using? Chromyl chloride. That is CrO2Cl2. Okay, chromyl chloride is CrO2Cl2. Okay, CrO2Cl2 is chromyl chloride. Okay. So what we are doing, chromyl chloride will oxidize your methyl group. So I take the methyl group, that is toluene. So it oxidizes the chromyl. Okay, that is, and it forms what? It forms chromium complex. It forms what? It forms chromium complex. That is CHOCrOHCl2. Okay. So this is a chromium complex. So this is a chromium complex which further undergoes hydrolysis, to give you aldehyde, Okay, so chromyl chloride, what it does, it oxidizes. So we are making this chromyl chloride, it is a oxidizing agent. Oxidizing It is a oxidizing agent. So chromyl chloride is an oxidizing agent. It oxidizes your methyl group to a chromium complex, okay, which is undergoing hydrolysis. Okay, it is undergoing acid hydrolysis to form a aldehyde. So you can see that your hydrogens are removed here, okay, and there is an addition of oxygen. So this is what? This is a oxidation reaction, okay, and this name reaction is called as what? Itard reaction. Okay, so Itard reaction, what we are doing, we are converting your this toluene, okay, toluene to benzaldehyde. So this is a Itard reaction. Okay, so this is the reaction. So we are making use of a solvent, that is carbon disulfide. So which particular solvent we are making use of? We are making use of carbon disulfide. Okay, so this is a particular reaction. Okay, next is Gattermann-Koch reaction. Next is what? Gattermann-Koch reaction. So Gattermann-Koch reaction, what we are doing? We are taking benzene. We are taking benzene or its derivatives can be taken. Okay, and it is treated with carbon monoxide. Okay, please remember the reagents. Don't get confused between the reagents. Okay, so which reagent we are making use of? We are making use of carbon monoxide in the presence of hydrochloric acid. Okay, okay, and we are making use of anhydrous AlCl3. So what it is? It is a Lewis acid, right? It is a Lewis acid. So anhydrous AlCl3 or cuprous chloride. Cuprous chloride. Okay, Cu+1. So it is cuprous chloride. So cuprous means what? Copper is in +1 state. So we are making use of carbon monoxide in the presence of hydrochloric acid. Okay, and anhydrous AlCl3, or we are making use of cuprous chloride, and we get benzaldehyde. So your benzene is converted to benzaldehyde by using Gattermann-Koch reaction. Okay, or you will get benzene substituted. So if you take a benzene substituted, then you will get benzaldehyde substituted product at the end. Okay, so depending upon what reactant you are taking, you will get the substituted product. So if I take only benzene, I'll get benzaldehyde. So if I take a benzene substituted product, a reactant, then I'll take a benzaldehyde substituted product at the end. Okay, so this is a Gattermann-Koch reaction. So please remember the definition, okay, and the particular reaction. Okay, so this is Gattermann-Koch reaction. Okay. Next is Clemmensen reduction. Okay, so this is a reduction reaction, Clemmensen reduction. So what we are doing here, your respective carbonyl group is converted into a methylene group, okay, or hydrocarbon. It is converted into hydrocarbon. So you can see there is a removal of oxygen and there is addition of hydrogen. Okay, so this is what? This is a reduction reaction. Okay, this is a reduction reaction. So we are making use of reduction. We are doing reduction here. Okay. So carbonyl group of aldehydes and ketones, it is reduced to CH2, that is hydrocarbons, when you are using zinc amalgam, ZnHg. ZnHg in the presence of HCl is nothing but zinc amalgam and hydrochloric acid. Okay, zinc amalgam and hydrochloric acid, and this reaction is called as what? Clemmensen reduction. This reaction is called as what? Clemmensen reduction. So the carbonyl group of aldehydes and ketones, it is reduced to CH2. Okay, on treatment with zinc amalgam and concentrated hydrochloric acid, and this reaction is Clemmensen reduction. So this is a reduction reaction. So which reagent we are making use of to convert the carbonyl group to CH2, that is hydrocarbon? This is a methylene carbon. Okay, we called it methylene carbon, CH2. Okay, we are converted into methylene carbon and we are making use of zinc amalgam. What we are making use of? Zinc amalgam. Okay, in the presence of hydrochloric acid. So this is a Clemmensen reduction. This is what? Clemmensen reduction. So we are seeing oxidation reduction. So these type of reactions only we can see, right? Now, next is Wolff-Kishner reduction. Okay, so another reduction reaction. Okay, wherein we are converting our this what carbonyl group to methylene group. Okay, and it forms in so there is an intermediate formation like imine. Okay, so there is a imine type formation in between, you can see. So what is done in Wolff-Kishner reduction? The carbonyl group of aldehyde and ketones, it is reduced to CH2 group. Okay, with treatment with hydrazine. What is hydrazine? NH2, NH2. Okay, NH2, NH2 is hydrazine. Okay, so if you treat the carbonyl group of aldehydes and ketones, okay, and it is reduced to what? CH2 group on treatment with hydrazine followed by heating. So followed by you have to heat it with sodium or potassium hydroxide. Okay, in the presence of ethylene glycol. Ethylene glycol. Okay, ethylene glycol is a solvent. Okay, and thus it converts your carbonyl group to methylene group. So this is the reduction reaction. So what is happening in Wolff-Kishner reduction? Your carbonyl group is converted into methylene group by treating it with hydrazine. Okay, so hydrazine followed by what? Treating it with your potassium or sodium hydroxide. Okay, in the presence of, you have to heat this. Okay, you have to heat it with potassium or sodium hydroxide in the presence of a solvent, that is ethylene glycol. You get methylene carbon plus N2. Okay, N2 is released. N2 is a gas. So a nitrogen gas will be released. So this is the Wolff-Kishner reduction. Okay, this is Wolff-Kishner reduction. Very important reaction. So these all named reactions are very important. Okay. Next is tolerance test. Next is tolerance test. What is tolerance test? So tolerance test on warming an aldehyde with freshly prepared ammonical silver nitrate solution. So what is tolerance reagent? Okay, remember what is tolerance reagent? Ammonical silver nitrate solution. Okay, ammonical silver nitrate solution. Okay, so Tallen's test is what? On warming an aldehyde with freshly prepared ammonical silver nitrate solution. Okay, what is Tallen's reagent? Tallen's reagent is nothing but ammonical silver nitrate solution. Okay, ammonical silver nitrate solution. Okay, so ammonical silver nitrate. So remember what is ammonical silver nitrate solution? It is Tollens reagent. Okay, what it produces, how it gives the positive test if it forms a silver mirror. Okay, if it forms a silver mirror, then it confirms that it is a Tollens reagent. Okay, so means that particular is a aldehyde. So if you so this Tollens test, it gives a positive test if you have a aldehyde. If a given compound is aldehyde. So on warming an aldehyde, so if you take a compound, if the compound is a aldehyde, okay, and you add the ammonical silver nitrate solution, that is Tollens reagent, okay, a bright silver mirror. How the mirror is there? Oh, so like that silver color mirror is formed due to the presence of silver metal because this ammonical silver nitrate solution, okay, it consists of AgNO3. Okay, it consists of AgNO3 plus ammonia. Okay. So silver mirror is produced, okay, and due to the formation of silver metal. So so whenever there is a silver mirror formation, this confirms that the given compound is uh, aldehyde. Okay, so what is happening here? The aldehydes are oxidized to carboxylate ion. Okay, so thus it gives you a silver color. So the why it because the aldehydes. Okay, so this is a reaction. That is Tollens reagent test. Okay, so this is a Tollens reagent test. You can see here, so that is aldehyde, and this is a your ammonical silver. Okay, you know that is it is alkaline. Alkaline means what? The solution that is ammonical silver because you are using ammonium hydroxide. This ammonium hydroxide is basic in nature. Okay, so the solution will be basic. So the medium is basic. Okay, alkaline, and we get a carboxylate ion. Okay, it is getting oxidized. Your aldehyde is getting oxidized to carboxylate ion. Okay, so the aldehydes are oxidized to corresponding carboxylate and ion. So this is Tollens test. This is Tollens test. Fine. Okay. Next is Felling's test. Next is what? Next is what? Felling's test. Okay. What is Felling's test now? Felling's test is another test. Okay. For aldehydes. Okay. Felling's test is another test which is used for aldehydes. So on heating aldehyde, so if you have a aldehyde and if you have a Felling solution, okay, what does Felling solution consist of? Copper, okay, it consists of copper sulfate solution, okay. Okay, so here Felling station, and it gives you a reddish brown precipitate. What it forms a reddish brown precipitate. Okay, so when if the given compound, if you treat it with Felling solution, okay, and it gives you a reddish brown precipitate, then means the given compound is what? It is a aldehyde. Okay, so what is happening here? The aldehydes are converted into corresponding carboxylate ion. Okay, and only your aliphatic aldehydes will respond to this particular test. Okay, aromatic aldehydes do not. What they do? Aromatic aldehydes, they do not respond to this test. Okay, that is aromatic means what? Aromatic means with benzene rings. Okay, aliphatic aldehydes can respond to this test, but aromatic, they do not respond to this test. So this is about Felling solution. So remember this test. Okay, just a second. Felling solutions. Felling solution. Okay, it is. Please remember this Felling solution or Felling's reagent consists of copper sulfate. Okay, that is, it consists of cupric sulfate plus sodium hydroxide, or I'll write the formula, that is sodium hydroxide. Okay. Sodium hydroxide and potassium sodium tartarate. Okay, potassium sodium tartarate. What is potassium sodium tartarate known as? Do you know? Potassium sodium tartarate, C4H4O6.4H2O. Okay, this is called as what? Potassium. So please remember this also, very important. Potassium sodium tartrate. Yes. Do you know what is potassium sodium tartrate called as? It is called as Rochelle salt. Okay, it is called as Rochelle salt. Okay, so please remember what is the composition of Fehling solution. Write it down. Copper sulfate dot 5 dot H2O, NaOH. Okay, and potassium sodium tartarate. Okay, potassium sodium tartarate, which is also called as Rochelle salt. Okay, it is called as Rochelle salt. So this is the what? Mm, Fehling solution. Okay, and only aliphatic aldehydes will respond to this test, and aromatic aldehydes, they do not respond to this test. Okay. Okay, so here you can see. Okay, so Fehling's reagent, it consists of two solutions, Fehling's A and Fehling's B. Okay, so Fehling's solution A, okay, it is made up of copper sulfate. Fehling's solution, okay, it is made up of two solutions, that is Fehling's A and Fehling's B. Okay, Fehling's A is copper sulfate solution. Okay, and Fehling's B is your alkaline sodium potassium tartarate. Okay, sodium potassium saltate, that is your Rochelle salt. Your Rochelle salt. Okay, so this is about your Fehling's A and Fehling's B. So together is a Fehling solution. Together is Fehling solution. Okay, remember this. Fine. Okay. Next test is Catanzaro test. Next is what? Catanzaro test. Okay. So next is what? Catanzaro test. Now in Catanzaro, what is happening here? Just see aldehydes which do not have an alpha atom. Okay. When aldehydes, when they do not have a alpha hydrogen atom, okay, they undergo self-oxidation and reduction. Okay, reaction on treatment with concentrated alkali. In this reaction, one molecule of aldehyde is reduced to alcohol while another is oxidized to carboxylic acid salt. Okay, it is converted to carboxylic acid salt. Fine. Then it is Catanzaro. So here, what do you mean by alpha hydrogen? Now here you can see alpha hydrogens. Okay. So alpha means what? Next to carbonyl carbon. Okay. Do you have a alpha hydrogen? Yes. So these are formaldehyde. So what is happening? They will undergo self oxidation. Alpha hydrogen means what? See here. Now, suppose you have CH3. Okay, so this is called as alpha hydrogen. So CH2 and H. So this is a alpha hydrogen. Okay, alpha hydrogen. So this is alpha carbon, right? So you don't have alpha carbon here. So there is no alpha hydrogen. So they do not undergo. So what they'll do, they will do not have an alpha hydrogen. So they undergo self-oxidation and reduction reaction. Okay, on treatment with the alkali. So this is a concentrated alkali, that is potassium hydroxide. Okay, so what is happening? One aldehyde will be reduced to alcohol. Okay, it is reduced to alcohol, and another is oxidized carboxylic acid salt. Okay, this is your Catanzaro reaction. So what is happening? So whenever you have two aldehydes, okay, when they do not have alpha hydrogen, they will undergo self oxidation and reduction. That is, it is called as disproportion reaction. Okay, that is one of it, one will undergo oxidation, another will undergo reduction. So the oxidation, okay, it will get oxidized. One aldehyde will get oxidized to form carboxylic acid salt, and another aldehyde will get reduced to form aldehyde. Okay, it will get reduced to aldehyde. Sorry, aldehyde is reduced to alcohol. Okay, so like this. So these are the Example. Okay, so this is the example. Fine. So the last one more. Okay, last name reaction is Hell-Bollard-Zelenki reaction. Okay, that is called as HVZ. The short form used is HVZ. Okay. So what is Hell-Bollard-Zelenki reaction? So a carboxylic acid. Okay, carboxylic acid which is having a alpha carbon. Now what is alpha carbon here? You see CH2, C double bond O, OH. Okay. So this is alpha. This is beta. So this is alpha. So it has a alpha carbon, right? So alpha hydrogen is there, right? Okay, so carboxylic acid, which is having a alpha hydrogen, are halogenated. What is done here? It is halogenated at alpha position on treatment with chlorine or bromine. Okay, we are treating it with chlorine or bromine in the presence of red phosphorus, and it gives you alpha halocarboxylic acid. So this reaction is Hell-Bollard-Zelenski reaction. Okay, so what we are doing, we are converting our carboxylic acid. Okay, next to carboxylic acid, that is next to carbonyl group, when you have a alpha hydrogen, so one of the alpha hydrogen is halogenated, okay, using chlorine or bromine, so it forms a alpha halocarboxylic acid. Understood? Okay, so this is Hell-Bollard-Zelenski reaction. Okay, so this is uh Hell-Bollard-Zelenski reaction. Okay, so this is the particular name reaction. So there are 10 name reactions in this particular chapter. Okay, so we have seen all the 10 name reaction. Any doubt till here? Yes, so these are the very important name reactions, students. Okay. Is it clear? Okay, fine. So, okay, so these name reactions. Okay, so the next is this one question. Okay, so that is the mechanism to show how you add the hydrogen cyanide. Okay, that is addition of hydrogen cyanide to aldehyde or ketones. Okay, addition of hydrogen cyanide. So how it takes place. So you can see. So aldehydes and ketones. Okay, whenever you have a carbonyl group, it will undergo addition reaction. It undergoes what? Addition reaction. So we are adding what? We are adding a molecule of hydrogen cyanide. So what is happening here? So cyanide. So addition of hydrogen cyanide. Cyanide is a nucleophile. Okay, cyanide is a nucleophile. So what is happening here? Just see here. So is this is a carbonyl carbon plus cyanide. So from your HCl, or when HCl splits, it gives you H plus plus Cn minus. Okay. So Cn minus is your nucleophile. So nucleophile will attack your carbonyl carbon and this will turn polarize the oxygen atom. Okay. So it forms what? It forms a Okay, it forms what? It forms a this intermediate. Okay, this is a tetrahedral intermediate. So four bonds are there. So tetrahedral intermediate, and this step is a slow step. Okay, attack of nucleophile on the carbonyl carbon of a aldehyde or a ketone, and this is a slow step because it forms a intermediate. Now, second step is what? In second step, it captures a proton. Okay, it captures a proton and it forms what? C OHCN. Okay, so it forms addition product. Okay, so this is a cyanohydrine. What it is? Cyanohydrine. So very important. Please make a note of this also. Okay, so two steps. Okay, the addition of hydrogen cyanide to aldehyde and ketone. So this particular this what question will be asked for 3 marks. So this is a 3 marks question. So there involves two steps. First step is a slow step where a nucleophile cyno attacks the carbonyl carbon, okay, and it forms a tetrahedral intermediate. Then in the second step, there is a capture of proton, okay, and it forms a cyanohedrin, and addition product cyanohedrin is formed. Okay, is it clear? Yes. Okay, we'll see some of the questions now. Okay. Okay. So give me some of the IUPAC names. Okay, I'll tell you some of the molecules. So please give the IUPAC name of these molecules. So like this, the question can be asked. Okay. Just a few minutes. Okay. So I'll write the compound name. So IUPAC names, it will be asked for 1 mark. Okay. So I'll write the IUPAC. Okay, I'll write the so CH3, CHO. Okay. Tell me the IUPAC of name of the following compounds. Okay. Ethanol. Okay. Vedvati has answered it as ethanol. Others? Yes, it is ethanol. Fine. Next one. CH3, CO, CH2, CH3. Yes, what is the name? IUPAC name? Butanone. Okay, here. How many carbon atoms? 4. Okay. CH3, C double bond O, CH2, CH3. So 1, 2, 3, 4. Okay. So butane to one. Okay. So at second position, you have double bond. So it is butane to all. Yes, it is butane, but to one. Okay. You have to name the position also. At 2, you have the one. Okay. Fine. Next one. CH2 double bond CH C. Okay. This. Yes, what is the name? Prop. Okay. 2 in 1, 2, 3. Okay. So it is prop 2 in all. Okay. All, not all. Because it is a aldehyde. So all, Al. Okay. Prop 2 in all. Okay. Last, CH3, C double bond O, CH2, CH2, CH3. This. Yes, students, what is the name? We have to number first. Okay, the first rule is what? Number. Start numbering. So 1, 2, 3, 4, 5. Okay. So now you can tell me it is pentane to ol. Is it? So it is pentane to ol. Okay. Fine. Okay. Next question. Acetaldehyde does not undergo Carinzaro reaction. Ethanol undergoes aldol condensation reaction. What is the reason? Acetaldehyde does not undergo Carinzaro reaction. Acetaldehyde does not undergo Carinzaro reaction. Ethanol undergoes aldol condensation reaction. What is the reason? Ethanol. I have written ethanol. It is ethanol. Okay, AL. Ethanol. Ethanol. Okay. The reason is it contains alpha hydrogen. Okay. It contains alpha hydrogen. It contains alpha hydrogen atom. Okay. The reason for both. So these are two different questions. Acetaldehyde does not undergo Carinzaro reaction and ethanol undergoes aldol condensation. What is the reason? Because it contains alpha hydrogen atom. Okay. Next, explain Rosenmund reaction. We have seen. Explain Stephen reaction. We have seen. Explain Rittard reaction. Explain Gatterman-Koch reaction. Explain Clemmensen reduction. Explain Wolff-Kishner reduction. Explain aldol condensation. Explain cross-aldol condensation. Explain Carinzaro reaction. Explain Hell-Wohlhard-Zelinsky reaction. So these are the important reactions. Okay, so we have seen all these name reactions, right? So I'll just give some more questions. Okay. Ketones are okay. Fine. I'll give you a question here. Ketones are generally less reactive towards nucleophilic addition reaction. Give any two reasons. Ketones are generally less reactive towards nucleophilic addition reaction. Give any two reasons. Yes, what are the two reasons why ketones are less reactive towards nucleophilic addition reactions? What are ketones? How is the ketones? This is the ketones. Okay. Why they are less reactive towards nucleophilic addition reactions? What are the reasons? First is what? Due to presence of that is due to steric hindrance. Okay, because both will be a alkyl or a aryl group. So first reason is due to steric hindrance. So because if so there can be two bulky groups. If two bulky groups are present on either side of the carbonyl group, then it is difficult for the attack to take place. Okay. So first is this reason. Next is electronic effect. Next is what? Electronic effect. Okay. So because there is no any negative charge. Okay. So polarization cannot take place fast. So these are the two reasons. Okay, why ketones are generally less reactive towards nucleophilic addition reaction. Okay. Okay, I'll give you a reaction. Please note it down. Okay. Give the IUPAC name of X. Okay. And name the reaction. This question is for 2 marks. Give the IUPAC name of X and name the reaction. Yes, students? What can be X? What can be X? What is X? TH3 and it is CH3I3. Okay. So the IUPAC name is triiodomethane. Triiodomethane. And the name of the reaction is haloform. Haloform reaction. Okay. Fine. Okay, so remaining questions, okay, such applicative questions, I'll take it in the next class. So one more class, we will do it for aldehydes and aldehyde ketones and carboxylic acid. Okay, I'll take some of the reactions. Okay, complete the following types. So some applicative type of questions, we'll take it from this particular chapter. It will be good for you also. Okay, it will be practice. So whatever has been taught today, please go through all the reactions. So based on those reactions only, the questions can be will be there. Okay. So any doubts in today's session? Yes, any doubts in today's session? Okay, fine. So so one more class, we'll take it for aldehydes, ketones, and carboxylic acid. Okay, after that, we'll be starting with amines chapter. Okay, we'll start with amines chapter. Fine. Okay, so I'll end the session here. Uh, I hope you have understood the things. Okay, so study hard. Okay, fine. So we'll end the session here. We'll meet in the next week. Thank you.